So today I'll be talking about the Trappist-1 star system, which is located around 40 light years away from the sun. So for my videos I'll be using Space Engine because Space Engine is one of the best simulations to help me describe my explanations better. So before I talk about the Trappist-1 star system, what is a star system? So we know about the solar system. Solar system is the sun and all the bodies, all the celestial bodies that orbit the sun. This could be planets, this could be asteroids, moons, and so on. Now, star system is more of a general term, and solar system is more like a proper noun. It's a game. It's a name given to our star system, which is the sun and its planets. That means all the stars that you see out there, they have their own star systems, and almost every single star in the Milky Way has at least one planet orbiting it, which is cool because that means there are so many opportunities. There are so many planets out there. If there are like 1 trillion planets, 1 trillion stars, then that means there are more than 1 trillion planets, which is crazy. Some of them can have life, some of them might not have life, but yeah, all of them are unique, all of them are special. So, Trappist-1 star system, what's so special about this? Trappist-1 star system has a red dwarf star, which is called Trappist-1. Trappist-1 is more like what the sun's future will be like. Sun right now is a yellow dwarf star, a yellow dwarf. It's in the prime of its life, 5 billion years old, but in 6, 7, 8 billion years, sun will become a red giant star, and from red giant star, in a few million years time only, it will become a red dwarf star, just like Trappist-1. Now Trappist-1 is a red dwarf star, like I said, and because it's a red dwarf star, it's not so active anymore. It's not in the prime of its life anymore. It's not a main sequence star fusing hydrogen actively. So less fusion, less to no fusion happening in these stars, which means the temperature is drastically lower than what a yellow dwarf star like sun would do. Sun's temperature is 5500 degrees Kelvin, and the surface temperature of a red dwarf star like Trappist-1 would be 2000 to 3000 degrees Kelvin, which is just like half of the sun's temperature, much lower. This also means that if planets, habitable planets, have to exist in these stars, they will have to be much, much closer than where the Earth is, so that there is enough temperature, it's warm enough for them to have life. So the Trappist-1 star system, which has the Trappist-1 star and all the other planets, this has a total of 7 planets orbiting Trappist-1 star. Trappist-1b, Trappist-1c, Trappist-1d, and so on until Trappist-1h. So Trappist-1h, farthest star, Trappist-1b, the closest star. And what's so cool about this is that because the star itself is like the core of the initial yellow dwarf larger star, because it's a red dwarf, right? The star is very small, it's old, it's cooling down slowly. So this star is very small. That means less gravitational force, and that also means less of the temperature, which means all the planets are actually much, much closer to the star than Mercury. That means Trappist-1h, the furthest star in their star system, if Mercury was to orbit the star, if Mercury was to orbit Trappist-1, Trappist-1h would be closer than Mercury. So this is actually very, very, very small compared to the orbits of Mercury, which is actually the closest star of our solar system. Sorry, closest planet. And yeah, so that's one cool thing already about the star system. And what's Trappist-1, the star, it's a red dwarf, and red dwarf stars usually they emit lots of solar flares, But what's something so special about the star is that this star in particular, this red dwarf star in particular, does not really emit lots of solar flares, which is good for any habitable planet orbiting it. More the solar flares, the easier it is for the atmosphere of habitable planets to be ripped apart, which means no life. That means more radiation, more risk of cancer to living organisms, and that means no chance of life. But yeah, this star emits less of those solar flares, which is good. And that means Trappist-1 D, E, and F, which actually lie in the habitable zone, are good candidates for harboring life. So obviously, this star system was found almost a decade ago. I reckon in 2016, which is 7 years ago from now, 2023. And scientists are continuously researching about the star system, so they keep on getting updated every 2 months or so. Recently, the James Webb Telescope was also launched, and one of the main missions of James Webb Telescope was to find out more about the star system. And yeah, it's been finding lots of more information. Turns out Trappist-1 B and C are actually too hot to have any life. Previously, it was thought that they were maybe also like somewhat there was some chance of having life, but no. Trappist-1 B's temperature could be closer to Venus's temperature. Trappist-1 C slightly cooler, but still Trappist-1 D, E, and F are best ones for life. Now, something special about this star system is that the planets are likely tidally locked. Tidally locked means the planets will not have any rotation around the star. I mean, they will revolve around the star, obviously, but they won't have their rotation like the Earth does, which could be a problem actually. But that also means that life can still exist. Let me explain how. Tidally locked means the one side of the planet will be facing the sun, facing the star at all times, and one side will not be facing the star at all times, which is bad because the side that will be facing the star will be continuously heated up in all the planets, leading to much higher temperatures than the other side of the planets, which will be facing away from the star, which means it will be much cooler. This shows that life in the extremes of the planets, all planets, is less likely. But that also means that the regions between the day side and the night side of the planets can have life. That will be the equilibrium point. That is the point where the hot and cold they mix together, which is quite which shows that yeah, that could be one region in Trappist-1 D, E, and F which will be having life. Temperatures will be stable. So yeah, that is Trappist-1 star system, and scientists have kept on researching about these planets. They have found lots of information, and yeah, the planets were found using the transit method. I mean, there are many methods of finding planets, exoplanets, to be specific, because exoplanets are planets that are not in our solar system, which means they orbit other stars. So these planets were found using transit method, which is one of the most famous techniques of finding planets, which I'll be talking more about later in some other video, hopefully. And yeah, so transit method gives a good confirmation that these planets do exist, because sometimes we find planets but then we are not sure whether they are planets, but these 7 planets we are sure that they exist. Now, Trappist-1 G and H, they are the outer planets of the star system. Scientists think that they might not have chances of having life. They might be too cold. All the planets are obviously bigger than the Earth, because the bigger the planet, the easier it is to be seen using telescope. So B, C are too hot. They are like hot Jupiters, or you can say they're like Venus. They must be having a thick atmosphere filled with CO2 or some other gases that are not specifically essential for having life around them. And Trappist-1 G and H are probably like cold Neptunes, or they must be like gas giants. which will be cold. So there's obviously no chance of them having life. So yeah, I think that is it for today, and yeah, I think this is it.